Hey students, this is a video on multiplying polynomials. Make sure you've already watched my other videos on polynomials, intro to polynomials, and adding and subtracting polynomials. Because multiplying polynomials is a little bit more challenging, and it's a bit of a different process. There's different ways of doing it based on how many terms your polynomial has. Okay? So let's jump into an example, and we will take a look at the different types of multiplication that can happen. But basically, you're either going to be using the distributive property, so you're going to be distributing one polynomial to the other, or if both polynomials are binomials, which means they both have two terms, you can use the very famous technique called FOIL. Okay? So example. Multiply, okay, so the instructions are multiply, and of course they just say multiply, but they also mean simplify, so they mean multiply and simplify. So they don't say that in the instructions, so I wrote it in red, but that's what they mean. Okay, so for our first example, we're going to be doing 3x times the quantity 5x plus 4. And when I say the quantity, I mean parentheses. Okay, so it's 3x times parentheses 5x plus 4. Now some of you may already know how to do this for one of your other math classes. Other people might not remember or need a refresher. So this is a pretty easy one because it's actually got a polynomial with just one term right here, the 3x. That's called a monomial. And that's multiplied times a polynomial with two terms. So all you have to do here is just distribute. Okay, so we're going to distribute the 3x to each of those terms. All right, so all we do is distribute. Okay. So for the first term, we're going to have 3x times 5x, 3x times 5x, and for the second term, we're going to have 3x times 4. Okay, so we have 3x times 5x plus 3x times 4. Literally, all I did was distribute the 3x to each of those terms. Okay, and you're always going to be distributing if you have a monomial, so a polynomial with one term, times a polynomial with more than one term. Here it's a monomial times a binomial. It's called a binomial because it has two terms. Okay, and then here you just need to simplify each of these terms. So for the first term, 3 times 5 is 15. So we have 15. And then x times x is x squared. So we have 15x squared plus 3x times 4 is going to be, 3 times 4 is 12x. So we get 15x squared plus 12x. And you can't actually simplify this anymore because these are not like terms. So this is x to the second power and this is x to the first power. So because they aren't like terms, we can't combine them. So this is going to be our answer. Okay? So that's an example of using the distributive property. Okay? And it's called the distributive property because you distribute your monomial to each term of the other polynomial. Alright, so for our next example, I want to do one where we have a negative that we're distributing as well as the monomial. Okay, so for example number 2, we have negative 4x times parentheses 3x squared minus 2x plus 5. Or as I like to say sometimes, negative 4x times the quantity 3x squared minus 2x plus 5. Okay? 3x squared minus 2x plus 5. All right, so here we actually have a polynomial with one term, which is a monomial, times a polynomial with three terms, which is called a trinomial, because it has three terms, just like a tricycle has three wheels. Okay, so if we distribute the negative 4x, we can do that here. So once again, we're just going to distribute. And the tricky thing here is to realize that because it's a negative 4x, we have to distribute the minus as well as the 4x. And the minus is going to end up multiplying times each term, and it's going to switch the sign of every term. Okay, so let's see how that looks. So for the first term, we're going to have negative 4x times 3x squared. For the second term, we're going to have negative 4x times negative 2x. Actually, let me write that in a slightly different way. Hold on. It's getting a little bit messy, so I wanted to write it in a different way. Okay, so we have negative 4x times 3x squared for the first term, and then we have minus 4x times negative 2x for the second term. And then for the last term, we have minus 4x times positive 5. Okay, and to represent the multiplication here, I went ahead and put parentheses around each term of the trinomial. So this polynomial here. Okay, so I distributed the negative 4x to each term. Notice there's a minus 4x at every single term. It's very important that you distribute the minus as well as the 4x to every term. Okay, and then for each of these terms, we need to multiply. Okay, so for the first term, negative 4 times 3 is negative 12. All right, and x times x squared, well, that's the same as x to the 1 times x to the 2. And recall from our rules of exponents, if you're multiplying exponentials with the same base, you add the exponents. So this is going to be x to the 1 plus 2, which is x to the 3. Okay, so it's going to be x cubed. So we have negative 12x cubed for the first term. For the second term, those minuses are going to cancel out because a minus times a minus makes a plus. And then we have 4 times 2 is 8, and x times x is x squared. So for our second term, we're going to have 8x squared. And then for the last term, negative 4 times 5 is negative 20x. So we have minus 20x as our last term. Okay, and notice that for all these terms, all the signs switched because we distributed a negative. So if you go back to the original problem, this polynomial that we started with on the right side was plus, minus, plus. But because we distributed the negative, all these are going to switch signs. So it became minus, plus, minus. Right? Minus, plus, minus. So that's just a good thing to notice, because if you're ever distributing a minus, basically all you do is you switch all of the signs. So you switch the signs of each individual term, and that's how you distribute the minus. Okay? Cool. So that one was a little bit more challenging, but still not too bad, hopefully. Okay. So now let's get into a even more challenging problem. Now this next one can look a little bit overwhelming. So we're going to be doing example number 3 next. And this one can be a bit much. Okay, so number 3 is actually negative y times parentheses 7x cubed minus 2x squared y plus xy squared plus 3y cubed. Okay, so once again we have negative y times parentheses 7x cubed minus 2x squared y plus xy squared plus 3y cubed. And that's quite an earful. I know, it's a lot to read. And when you're doing a problem like this, one of the hardest things is just keeping track of everything and making sure you copied it down correctly on your paper. So you might want to double or even triple check it. Negative y times the quantity 7x cubed minus 2x squared y plus xy squared plus 3y cubed. So we did write it down correctly. Okay, so this is actually a monomial, a polynomial with one term here, times a quadrinomial. Quadrinomial means it has 4 terms. And I think our book doesn't even call it a quadrinomial. They don't even have that name. Okay, but once again, if you have a monomial times another polynomial, you're basically just going to distribute. So once again, we distribute. So we're going to be distributing the negative y to every single term. So that's a total of 4 terms. And the terms are kind of complicated because they have 2 variables. All right, so let's see how that's going to work. Well, first of all, when we're distributing the minus, basically all that's going to do is it's going to switch all the signs. So right now, the signs are plus, minus, plus, plus. If we switch all of those signs, now it's going to be minus, plus, minus, minus. Okay, so let me write that down. Minus, plus, minus, minus. Okay, and I left myself lots of room to write everything, hopefully. Okay, so then for the first term, we're going to have minus y times 7x cubed. Okay, so y times 7x cubed. For the second term, we have y times 2x squared y, y times 2x squared y. For the third term, we have minus y times xy squared. And for the last term, we have minus y times 3y cubed. Okay, but if you find it hard to do switching the signs in your head, you can actually write it out like I did the last problem. But what I did there is I took a little shortcut and I said, oh, well, if I'm distributing a minus, I basically just switch all the signs. So plus, minus, plus, plus became minus, plus, minus, minus. Okay, but if you find that confusing, you can write it out like I did on the last problem. But you're going to find that for this problem, this term right here, the second term, is going to have a minus y times a negative 2x squared y. So those minuses cancel out, and that's why we have a plus here. Okay? All right, so I know it's very messy looking, so once again, if you're doing a hard problem like this, you might want to check through and make sure you didn't forget anything. Okay, and now we can go ahead and multiply these. Now remember, you can combine variables that are exactly the same variables, but you can't combine different variables. So like for this first term, the x cubed and the y cannot be combined. So you just write them separately. So what we have here is negative 7x cubed y. And it's a convention to write the letters in alphabetical order. That's why I wrote the x first and the y second. And it's also a convention to have the number or the constant out front. So that's why it's negative 7x cubed y. We cannot combine these though because they're different variables, so we just leave it that way. Now for the second term, we notice that we actually have a y times a y. Well, what's y times y? Everyone should know that that's y squared, or y to the second power. Okay, so for the second term, we're going to have plus 2x squared y squared. And once again, you can't combine the x squared and the y squared because they're different variables. So you just write them in alphabetic order and you're good. Okay, for the third term, here we have, once again, a y, and then we also have a y squared. So that's the same as y to the 1 times y squared. So that's going to be y to the 1 plus 2, which is y to the 3, or y cubed. Okay, so we're actually going to have minus x y cubed. So all I did there was I added the exponents of the y's because they were the same variable. So I did y to the 1 plus 2, which is y to the 3. Okay, and then for the last term, we're still doing the same thing. So for this last term, we have y to the 1 here times y to the 3 inside there. So adding those exponents, we have y to the 1 plus 3, which is y to the 4. Okay, so for our last term, we have minus 3 y to the 4. So hopefully that makes sense when I explain it in great detail like that. And of course, once you get comfortable with them, it won't take as long as it takes me to explain it. Okay. But one of the nice things about my math lab is it will instantly give you feedback. And if you made one little mistake anywhere, it will notice. And it'll either tell you what's wrong, or it'll just tell you that it's wrong and you have to figure out where your mistake was. But I see that we got the same answer as them, so that's good. We got that. Okay, so I'll go ahead and box that. So that's about as messy as that type of problem gets in your homework. So I wanted to move on to the next type of problem. So we're still multiplying polynomials, but now we're going to be multiplying a binomial times a binomial. Okay, so this is going to be example number 4. Example number 4. So for example number 4, we have x plus 6 times x plus 3. Okay? X plus 6 times x plus 3. So this is a binomial times a binomial. And the standard way to do a binomial times a binomial, in other words, 2 terms times 2 terms, is FOIL. Okay? So this is the one case where you don't usually want to use the distributive property. You actually want to use FOIL. So what does FOIL stand for? Well, many of you probably already know it, but for those of you who do not, FOIL stands for first, outer, inner, last. Okay, so first, outer, inner, and last. And FOIL is basically a shortcut that you can use for multiplying a binomial times a binomial. Okay? So it only works for a binomial times another binomial. Binomial times another binomial. So I wrote binomial with parentheses around it, binomial, to mean a binomial times another binomial. It won't work for a binomial times a trinomial. It won't work for a monomial times a quadrinomial. It won't work for any of the other ones. But it is a shortcut, and it's faster for a binomial times a binomial. And that means 2 terms. So binomial means 2 terms. So 2 terms times 2 terms. Okay, so it's first, outer, inner, last. And what that means is first would mean you multiply the first of the terms. Okay, so let me write it down here. First, outer, inner, last. You're actually going to be adding here, so it's going to be first plus outer plus inner plus last. As you can see, that's FOIL. And of course, sometimes the terms may be negative. Okay, but it's still first, outer, inner, last. So with this one, the first is actually going to be x times x. And some people like to draw the crescent underneath it to show what they're multiplying. So here the first is x times x. Excuse me. So those are the first terms of each binomial. Okay, so here first is going to be x times x. Okay, and then we have plus the outer. So what's the outer mean? Well, the outer are going to be the outer terms. So that here, that's going to mean x times 3. That's going to be our outer. X times 3. Okay, so our outer is x times 3. And then we have plus our inner. So our inner terms here are going to be the ones on the inside. So that's going to be 6 times x. Okay, 6 times x. Six times x. And then we have plus the last. So what are the last terms here? Well, the last terms are going to be the 6 and the 3. So it's going to be 6 times 3. Okay, so after we do all of that, we've actually taken kind of a shortcut. FOIL is generally the fastest way to do a binomial times a binomial, which is why people learn it. So I know it's taking a long time for me to explain it the first time, but once you get used to it, it's actually really fast. Okay, so what you do now is you're going to combine like terms. Well, first of all, you're going to multiply to simplify, and then you're going to combine like terms. So x times x is x squared. X times 3 is the same as 3x. Remember, you write your coefficient first and your variables second. And then we have plus 6x. And then plus 6 times 3 is 18. So we have x squared plus 3x plus 6x plus 18. Okay, so that was just multiplying the first, the outer, and the inner, and the last. But now we can actually simplify this a little bit more by combining like terms. And generally with FOIL, the only like terms are usually going to be the outer and the inner. Okay, so here our like terms are going to be 3x and 6x. For the other like terms, we have an x squared by itself and an 18 by itself. But those can't combine because they're different powers. Okay, so our highest power is going to be x squared, and then combining the outer plus the inner, we're going to have 3x plus 6x, which is 9x. Okay, so we have x squared plus 9x plus 18. Okay, x squared plus 9x plus 18. And even though I explained every little part of it, it still didn't take us that long. That's actually the whole problem. And of course, once you get fast at it, and you don't have to explain it, you just have to do it, this is actually considered the fastest way to do a binomial times a binomial. Of course, they can get more challenging when you have minuses or different powers. So I wanted to give you a couple more examples. Okay, so for example number 5, let's take a look at this one. So this one is parentheses 2x squared plus 5 times parentheses 6x squared plus 7. Okay, so once again we have parentheses 2x squared plus 5 times parentheses 6x squared plus 7. So what we have to do here is we have a binomial times a binomial, which means we're going to be using FOIL. So on this one we have powers that are a little bit bigger, but we're still going to be using FOIL. Okay, so we're still going to be using FOIL. So first plus outer plus inner plus last. So here the first is actually going to be 2x squared times 6x squared. Okay, so 2x squared times 6x squared is the first. And then we have plus the outer. So here our outer is going to be 2x squared times 7. Okay, 2x squared times 7. And then we have plus the inner, which is 5 times 6x squared. 5 times 6x squared. And then we have plus the last. And here the last is actually just going to be 5 times 7. Okay, so we have plus 5 times 7. Now this one's harder because it actually has more numbers, it has coefficients, and it also has x raised to a power. So it makes it more challenging. But we still use all the same rules here. So if we're doing 2x squared times 6x squared, we multiply the coefficients. So 2 times 6 is 12. And then we add the exponents. So we're going to have x to the 2 plus 2 is 4. So we're going to have 12x to the 4th for the first term. Now for the second term, multiplying 2 times 7, we get 14x squared. And there's only one variable, so there's nothing to combine it with. Same thing for the inner. For the inner, we have the coefficients, which is 5 times 6, and that's going to be 30. So we have 30x squared. Okay? And so our inner is 30x squared, and then our last is going to be 5 times 7, which is 35. So we have plus 35 at the end here. Okay, so we have 12x to the 4th plus 14x squared plus 30x squared plus 35. Okay, and then where do we go from here? Well, just like in the last problem, you need to combine like terms. But also, just like the last problem, the only like powers here, or like terms, are going to be the outer plus the inner. So the outer plus the inner is going to be 14 plus 30, which is 44x squared. So we have 12x to the 4th plus 44x squared plus 35. And that's our answer. And get used to combining the outer and the inner, but not having to combine the first and the last, because that's how it works out 99% of the time. Okay? So that was a harder FOIL problem. Now I wanted to show you one that has a square, and I also wanted to show you one that has a minus. So I think I'm going to take care of both of those in the same problem. So let's take a look at this next one. Okay, so that was example number 5. So this next one is going to be example number 6. So for example number 6, we're going to be working on parentheses 9y minus 8 parentheses squared. In other words, the quantity 9y minus 8 quantity squared. So here you have to be careful. I know I've told you before that you can distribute the square or you can distribute the exponent. However, remember when I taught you that rule, you had to have only one term. The problem is here we have two terms, which means we can't distribute the square. So you can't distribute the exponent if there is more than one term. Okay? You can't distribute the exponent if there is more than one term. Now the reason for that is pretty complicated. We're not going to go into that, but that's the rule. Now you got to follow the rules, otherwise you're going to end up with a wrong answer. And of course, if an engineer gets the wrong answer, they design a bridge incorrectly and the bridge collapses, which could be disastrous. So it is important to do your math right, particularly if you're an engineer. Okay, so you can't distribute the exponent if there is more than one term. That's something that confuses people, but here we actually have two terms, which is more than one term, so you can't distribute the exponent. So what do you have to do instead? What do you have to do instead? Well, you can rewrite it as 9y minus 8 times 9y minus 8. And then you can use FOIL. So that's the trick. Okay? So we can rewrite it as 9y minus 8 times itself. Because remember, an exponent of 2 means that you multiply 9y minus 8 a total of two times. So there's two factors of 9y minus 8. Okay, so because the rules of math and the universe say that we can't distribute the exponent if there's more than one term, we have to do the next best thing, which is to rewrite it as 9y minus 8 times itself. And then, like I was just saying, here we have a binomial times a binomial. So how do we do that? We multiply it out with FOIL. Okay, so first, outer, inner, last. Okay, so here the first is going to be 9y times 9y. Okay, that's our first. And then our outer is going to be 9y times negative 8. Okay, so we have plus 9y times negative 8. And then our inner is going to be minus 8 times 9y. And then our last is going to be negative 8 times negative 8. First, outer, inner, last. And I got lazy and I didn't write the crescents because I didn't feel like drawing them again. Okay, and then we're going to multiply each of these out. So for the 9 times 9, that's going to be 81 for the first. So we have 81, and then y times y is y squared. So we have 81y squared for the first. For the outer, 9 times negative 8 is going to be negative 72. So we have negative 72y for the outer. For the inner, negative 8 times positive 9y is also going to be negative 72y. And then for the last, negative 8 times negative 8, well, two minuses makes a plus when you are multiplying or dividing. So those minuses cancel out and give you a positive 8 times 8, which is 64. Okay? So you should have 81y squared minus 72y minus 72y plus 64. Okay, and then all we have to do with this is combine the outer and the inner. Okay, so combining the outer and the inner, what is negative 72 minus 72? Well, because they're both negative, we're going to be keeping the sign and adding. So 2 plus 2 is 4, and 7 plus 7 is 14. So I got 144, but it's negative because they're both negative. So here I have negative 144y. Or you can write it out vertically, but you're going to see 2 plus 2 is 4, and then 7 plus 7 is 14. Okay? So that gives you 144. But it's negative because they were both negative. Okay, so we have 81y squared minus 144y plus 64. Okay, and that's going to be our answer for that one. And then you have one more problem in your homework where you have a larger power and you have a square. But just remember, whenever you have a square and there's more than one term, you cannot distribute the exponent. You can't distribute the square. So at the beginning here, I know it looks so tempting. You would think that you could distribute this square to each of those factors. So you would think you would get 9y squared minus 8 squared, right? So that would be 81y squared minus 64. Or maybe plus 64. That's not correct. So you cannot do that. Because if you did that, that's not the answer we got. And we did it correctly here. So there's this negative 144y in the middle, and distributing the square would have skipped that. Okay, so distributing the square would have just given us the first term and the last term. I guess it would be a plus 64, but you wouldn't have the middle term. So that's why you have to use FOIL and not distribute the square. Okay, so there's just one more type of problem for multiplying polynomials. Okay, so this next example is example number 6. Is that right, or is it 7? We just did example number 6, so this is number 7, sorry. Okay, so this is example number 7. I'm just going to do one example of this because there's only 2 of them on your homework and they're both very similar to each other. Okay, so what we're doing here is probably the hardest thing that we've learned, which is, what do you do if you have a binomial times a trinomial? You can't use FOIL. I mean, I guess you could use FOIL, but it would be very confusing, so I wouldn't recommend it. So what we have here is a binomial, which is x minus 3, times a trinomial, which is going to be x squared minus 6x plus 7. Okay, so we have x minus 3 times the quantity x squared minus 6x plus 7. So because it's actually a binomial times a trinomial, so the first one has 2 terms, but the second one has 3 terms, so it's called a trinomial. You're not allowed to use FOIL here. FOIL doesn't work. Okay, so you can't use FOIL because FOIL only works for a binomial times a binomial. You can't use FOIL. So if you can't use FOIL, what do you have to do? Well, there's 2 ways of doing it that I know of. The first way is what I recommend to most people, which is to distribute. Okay? So when I say distribute, it's a little bit confusing, but basically you distribute this x to every single term there, and you distribute the negative 3 to every single term in the second polynomial. So you're going to have a total of 6 terms, because 2 times 3 is 6. Now, this is the way I like to teach it. The other way I know of doing it is called the box method, but I generally find the box method to be more extra work, and I have never found it as useful as just distributing everything. Okay, so I'm just going to teach it the way I like to teach it, but if you have another way of doing these, you're welcome to do it that way. But I like to just teach it one way and the way that seems easiest to me. Okay, so since we can't use FOIL, the way I'm going to teach it is we distribute okay, so we distribute. Now when I say distribute, it's a little bit tricky because we actually have x minus 3, it has 2 terms. So what I'm going to do is we've got the x, so we have to distribute the x to every single term in the second polynomial, but we also have to distribute the negative 3 to every single term in the second polynomial. Okay, so we also have to distribute this minus 3 to every single term in the second polynomial. And I'm using two different colors so that you can kind of see what I'm doing here. So what I'm saying is when I say distribute, well, because it's a binomial, it has two terms. You have to distribute this term to every term here, and you have to distribute this term to every term there. So let's start with the x. If we distribute that to every term, in red there, we're going to have x times x squared. It's going to be the first term. So I'll do that in red so you can see it. So we have x times x squared. And then we have x times negative 6x for the second term. Okay, so plus x times negative 6x. Okay, and then we have plus x times 7 for the third term. So plus x times 7. And then now I'm going to switch to green, because all we distributed so far was the x. Okay, that was our first term here. Now we have to distribute this second term, which is negative 3. So distributing the second term to each of those, we have negative 3 times x squared. Okay, so let me zoom out a little bit so I have room. So for the first term, we have negative 3 times x squared. And then for the second term, we have negative 3 times negative 6x. So negative 3 times negative 6x. And then for our last term in green there, we have negative 3 times positive 7. Okay, so we have negative 3 times positive 7. Okay, and I had to zoom out because there's so many terms here. Okay, so this is obviously a lot harder than the other problems we've done just because there's so much going on. But now we can go ahead and multiply each of these, and then we're going to combine like terms. So I'm just going to switch all this back to black now that we've written out all the terms. Okay, so for the first term here, adding the exponents, we have x to the 1 plus 2 is going to be x cubed, or x to the third power. For the second term, adding the exponents, we have negative 6 times x is x squared. So we have minus 6x squared. Okay. For the third term, x times 7 can be rewritten as 7x, positive 7x. Okay. For the fourth term, negative 3 times x squared is negative 3x squared. Okay. For the fifth term, the minuses cancel. Okay, so these minuses are going to cancel. 2 minuses makes a plus when you're multiplying. So we get positive 3 times 6 is 18x. So we have plus 18x. And then for the very last term, negative 3 times 7 is negative 21. Okay, so we have x cubed minus 6x squared plus 7x minus 3x squared plus 18x minus 21. And now we can combine like terms. So here, writing symbols underneath it can really make it easier to determine which ones are like terms. So we've got an x cubed by itself, and then we have a negative 6x squared and a negative 3x squared. So I'll put symbols under those. We're going to combine those. And then we have a 7x and an 18x. So I put the same symbol under those. We're going to combine those. And then we have a negative 21 by itself. Okay? So writing the highest powers first, we have x cubed, and then we have negative 6 minus 3 is going to be negative 9x squared. And then combining the x's, we have 7x plus 18x is actually positive 25x. right? Because 7 plus 18 is 25. Okay? And then for our last term, we just have minus 21. So we got x cubed minus 9x squared plus 25x minus 21. And that's actually the answer that they got on my math lab. Now the other way of doing this would be the box method. I don't like to teach the box method because it's not as fast as the way I do it. I think my way is the fastest way, as long as you don't get confused when you're doing it my way. But if you prefer the box method, you're welcome to use that. Okay. All right. So that takes care of that one. And then your other homework problem is similar to this one. So we don't need to see another example. And I just wanted to talk briefly about checking these problems. Probably the easiest way to check these is to just read through your steps. So for example, when we distributed everything, make sure that you distributed everything correctly. And then to check your work, the next thing you would do is make sure that you multiplied each of these correctly. And then your last step would be to check to make sure that you combined like terms correctly. And if you're checking like that, you can always use a calculator to make it easier. Just in case you're not sure that -6 minus 3 is -9 or something like that. Okay? So that concludes this lecture. Thank you for watching.